Hey everyone, welcome to The Explainer. If you're a CS student trying to wrap your head around how modern web apps are actually put together out there in the real world, you are in the exact right spot. Today, our overarching goal is to completely demystify the architectural patterns of modern web applications. We're going to be specifically focusing on the really incredible tools inside the Laravel 13 front-end ecosystem. Basically, we are unpacking the modern architect's tool belt.
Now, before we start climbing through these different layers of front-end complexity, I definitely want to acknowledge our source material for today. We're drawing from this really excellent module produced by the Computer Communication Development Institute. So think of this explainer as your accelerated, top-tier university lecture on scaling an application, going from basic rendering all the way up to some highly performant client-side mechanics.
Okay, let's dive into this. Here's our syllabus for today, just to give you a quick mental roadmap of the paradigms we're going to cover. We'll start with the Laravel front-end landscape, then hit component-driven design with Blade. Next is assets, bundling, and Vite, followed by server-side reactivity with Livewire. Then we'll look at the hybrid SPA using Inertia.js, and finally wrap up with choosing your tech stack.
All right, kicking things off with Section 1, the Laravel front-end landscape.
Let's start by framing a massive historical problem in web development, one you've probably already bumped into during your coursework. For years, the web development ecosystem separated back-end architecture and front-end development into completely isolated silos. I mean, developers had to build these incredibly complex APIs on the back end for the sole purpose of serving data to a totally separate JavaScript application on the front end. It was tedious. But Laravel 13 absolutely disrupts this division. Instead of that hard split, you get a unified ecosystem. It's a cohesive, high-performance environment that accommodates everything. Whether you're building a straightforward monolithic site or a fully decoupled single-page application, Laravel brings it all under one roof, beautifully solving that macro-level divide between front and back-end engineering.
Moving right along to Section 2, Component-Driven Design with Blade.
Okay, so moving up the architecture ladder, we hit our foundational rendering layer, Laravel's native templating engine, called Blade. Now, what exactly is component-driven design? In short, it's the practice of isolating layout templates, styles, and behavioral logic into highly reusable components. Think of these components exactly like Lego blocks. You obviously don't want to build a massive, repetitive web page from scratch every single time, right? Instead, you build individual pieces, like a user profile card or an alert banner, and you just cleanly snap them together. This drastically reduces repetition and keeps your presentation layer super clean. To connect this directly to your CS coursework, think of a component exactly like an object-oriented programming class. In OOP, as you know, a class encapsulates its own properties, state, and methods. Well, a Blade component does the exact same thing, just for your user interface. It encapsulates its own rendering logic and state. You write it once, and then you just instantiate it wherever it's needed in your system. It's a really powerful mental model. And this brilliantly illustrates how Blade gives you options based on what you actually need to build. There are two main structural patterns here. First, we have anonymous components. These are file-only, pure presentational layouts. There's zero backend logic involved, making them absolutely perfect for simple UI wrappers. On the flip side, we have class-backed components. This pattern pairs a dedicated PHP logic file with your view layer. You'd reach for this when your component needs to explicitly normalize data, talk to a database, or handle complex state injection right before rendering.
Which brings us to Section 3, Assets, Bundling, and Vite.
So, now that we have our UI Lego blocks defined, how do we actually style them and compile them for production? Well, within this ecosystem, you basically have two default avenues for styling. First up is Tailwind CSS. It's a utility-first framework that relies on micro-utility classes placed directly inside your HTML. The real magic here is that it automatically purges any unused styles during compilation, which keeps your production bundle sizes incredibly tiny. The alternative is Bootstrap, which is an absolute industry standard. Instead of micro-utilities, Bootstrap gives you highly stable pre-built UI components. It's fantastic for the rapid development of things like internal enterprise dashboards.
But how are we compiling all these styles in JavaScript files? Let's take a quick look at the old asset pipelines versus modern build tools. Legacy Webpack had to systematically parse your entire codebase, and that honestly resulted in some agonizingly slow development server reloads. Thankfully, Laravel 13 uses Vite asset bundling by default. And guys, this is a massive engineering upgrade. Vite serves your source code natively over ECMS modules, or ESM, delivering near instantaneous hot module replacement. Basically, you hit save, and your browser updates instantly without doing a full page reload. It is a huge win for developer experience.
All right, let's step it up a notch. Section 4, server-side reactivity with Livewire.
So let's escalate the complexity. How do we get that snappy, real-time reactivity of a modern web app, but without having to write heavy, completely separate JavaScript APIs? Let's walk through how this builds using Livewire. I really want to appeal directly to your algorithmic thinking here, so let's break down the exact step-by-step Livewire round-trip lifecycle. Step 1, Livewire renders the initial HTML on the server via a standard HTTP request. Step 2, it intercepts a user interaction, like maybe typing in a search bar. Step 3, it fires an asynchronous AJAX request back to the server, silently re-executing your PHP logic. And Step 4, Livewire intelligently mutates only the modified parts of the browser DOM, the document object model. The result? You get this incredibly smooth SPA-like reactivity, but you're writing the entire thing in pure PHP.
Now, Livewire's lightweight partner in crime is Alpine.js. It's a minimal, declarative JavaScript framework that lets you inject localized reactive state directly into your HTML markup using super simple directives like xdata and xshow. Think of it this way. If Livewire handles the complex server-side data mutations, Alpine handles the really fast, localized DOM manipulation, like toggling a drop-down menu or popping open a modal, without you needing the structural overhead of a massive JavaScript build step.
Moving right along to Section 5, the hybrid SPA with Inertia.js.
Okay, so now we are transitioning to the most advanced architectural paradigm in our stack today, the fully decoupled single-page application. Inertia.js is just a brilliant piece of engineering. It essentially bridges Laravel directly to modern JavaScript frameworks like Vue or React. Here's how the mechanics actually work. It replaces your presentation layer entirely, but keeps the Laravel backend completely intact. It intercepts standard link clicks to fetch a lightweight JSON payload instead of a whole new HTML page. And crucially, it completely replaces the traditional client-side router, wiping out the need to build and maintain a separate REST or GraphQL API. Your Laravel controller literally just passes data directly to your React or Vue components as standard properties. It's amazing.
Finally, let's bring it all together in Section 6, choosing your tech stack.
We have definitely covered a lot of ground today, escalating from basic server rendering all the way to hybrid SPAs. So the crucial point here is synthesizing all this so you know exactly when to use what. Are you building a content-heavy application where SEO and lightning-fast initial load times are absolutely critical? Go with Blade and Tailwind for a minimal bundle. Do you need dynamic, real-time forms and direct database interactivity, but you don't want the overhead of an API? Choose Livewire and Alpine for a pure PHP workflow. But if you're building a highly interactive app with complex client-side state management or offline capabilities, well, that's when you commit to the true SPA experience using Inertia paired with Vue or React. Which brings us to our final and most important question for you. Based on your project's specific technical scope and runtime needs, what architecture are you going to choose for your next big build? As computer science students, you now have the clear mental models of these architectural patterns. The theory is laid out, the tools are completely unified, and honestly, the only thing left to do is to open your editor and start writing some code. Thank you so much for joining me on this explainer. I hope you found this ecosystem as fascinating as I do, and I will see you in the next one.